Hey everyone, so this is lesson number 19. We're talking about the definition of the derivative again today. All right, so start by finding the tangent line to the graph at x equals 2. So like before, you could either do the limit as h approaches 0, or the limit as x approaches 2. I think it's a little easier / faster to do x approaches 2 when you're given a number. So -2 over x plus 3 minus, what do we get when we plug in 2? -2 over 5. So plus 2 over 5 all over x minus 2. I need a common denominator. So times 5 times 5 times x plus 3, x plus 3. That becomes -10 plus 2x plus 6 all over 5, x plus 3, x plus minus 2. So then what do we get here? The top, that becomes 2x minus 4, which is 2 times x minus 2. The x minus 2's cancel, so we have the limit x approaches 2 of 2 over 5 times x plus 3. We can plug in now and we get 2 over 25. So then it wants the tangent line. So I have my slope, right? This is m. I just found my derivative, which is slope. I have my point 2. I need the y value. What was the y value when we plugged in? -2 over 5. So my tangent line is y plus 2/5 equals 2 over 25, x minus 2. Okay, when does a function have a point that is not differentiable? So we kind of talked about this yesterday. Just like with continuity, where the limit from the left has to equal the limit from the right, with the derivative, the slope from the left has to equal the slope from the right. So if you look at a corner like that, just the regular x squared, the slope from this side at 0 is 1. The slope over here is -1. So because the slope from the left and the slope from the right are different, there's no derivative there. A cusp is basically the same thing. Right, so if you have something like this, the x to the 2/3, the slope from the left and the right are different. And then a vertical tangent line. So that's this. So if you actually have a tangent line that goes through the graph, basically a good rule of thumb for this, anytime you have a root where this, when you take the derivative of it, it becomes a negative, that's when you have a vertical tangent line. All right, show that f of x equals x minus 2 has no derivative at x equals 2. So if we go through and try to find the limit, right, let's go through and find the derivative. My pen's not working. So we're at a point, so we're going to do the limit x approaches 2 of f of x minus f of 2 is 0, over x minus 2. Okay, so I'm going to erase the 0 because that's silly. We don't need that. All right, now what can I do to simplify here? We're just dividing, right? We're dividing things that are the same. What do you do to exponents when you divide? It becomes negative. So this is the limit as x approaches 2 of x minus 2 to the -1/5, 4/5 minus 1. That's the limit as x approaches 2 of 1 over x minus 2 to the 1/5. There's no derivative there, right? We can't find that limit because that will give us 1 over 0, so the derivative does not exist, right? D and E because that gives us either infinity or negative infinity. And it's actually different on both sides, right? If we plug in a positive, we get from the right, we get a positive infinity. From the left, we get a negative infinity. So that does not work. So the limit as x approaches 2 from the left is negative infinity, but the limit as x approaches 2 from the right so the slope from the left and the right are different. Okay, so now let's look at some sketching. I did post these pictures, so if you want to print them out. Okay, so sketch the graph of f prime. So this is just a line, right? So what's the slope of this line? Well, I got that point. It looks like the slope is 2. So at x equals 0, what's the slope? 2. At x equals 1, what's the slope? 2. At x equals negative 1, what's the slope? 2. So the slope of a line is a horizontal line. That's it, okay? A little more complicated. So now think about the slopes that we actually know. What is a slope that you know? Like think about like a tangent line. What tangent line do you know automatically? Well, if you look at these, what's the not even that one really. What's the slope of the tangent line there? Pretty much anywhere you have a min or a max, the slope is 0. So what I'm going to do is I'm going to go through. This is my derivative. So here we got like a 0 there and a 0 there. All right. So now to the left, what's happening here? What's the tangent line? The tangent line is a positive. So that means the tangent line's above the x-axis. Then over here, our tangent line, our slope is negative, so it's below the x-axis. And then it goes up again. Now this one's, it's not very steep, right? So maybe I'm not going to go very high. And that's the basic sketch, right? We're just doing a sketch. This is not exact, but that's the basic sketch. So I look at what's the tangent line. If it's positive, it's above the x-axis. It's negative, it's below the x-axis. All right, so now using that idea, try this one on your own. Pause the video. All right, so I got a 0 there, a 0 there, there, there. So this is a positive, so above, and then it goes down, below, goes up. Not for long though, right? And now that's super steep, so this one, that's a really steep, so I'm gonna go like way down and then way up. Wow, that's so ugly. That's okay, that's about what it looks like. All right, where is f neither continuous or differentiable? So what do you think? Pause this video. So anywhere it's not continuous, it's not differentiable. So let's start with continuous. This thing is not continuous at -1, 2, and 7. Now, are there any places where it's also not differentiable? And why? It is not differentiable at this point right here. That's a cusp or a corner. I would call that a cusp because it's curved. So x equals 5. Where is f continuous but not differentiable? That's that x equals 5. Even though it's continuous there, the slope from the left and the slope from the right are different. So x equals 5. That's it. And there's your homework. This one not too bad of a day. All right. Email me if you have questions. Have a fabulous day.